Good morning everyone. So as of yet I haven't received anything from any of you for your first lesson, which I would hope to have done by now. Having said that, I didn't put it so that you could submit stuff onto the thing on class chart, so I've gone back and changed that. If you can get to that and upload any work to there, that would be awesome. If not, just email it to me. But year 10 and year 11 have managed to do it, at least some of them have. So there's no reason why you can't do it. And it is important that we do start to do that. Now today's video is going to be considerably shorter than yesterday's mammoth one. There's only one example I'm going to be showing you, and then it may well be I will put up the work for yesterday's and today's, because it all comes from the same exercise. And there's a big raft of questions in that exercise that I haven't asked you to go for, all that you may notice, all with things like arc sine and arc cos and stuff. You don't need to worry about that. It's in the book as a bit of a mistake. The new book coming out now, if you were to buy it, wouldn't have that in there, and the online version doesn't either. So that's why that's going on, in case you're worried about that. All right, so let's crack on and do a little bit more differentiating trig functions, because you know that's the sort of algebra that really sorts stuff out. So just to recap, the three rules we've been using for a little while now. Start off with the chain rule, which we use whenever we've got a function in a bracket, so something like x cubed minus x all in a bracket to the power 3 or something. We let that equal u, but you can use it for things that are a little simpler as well. And for that we need to do dy by du and then times that by du by dx. Then we've got the product rule, where you've got two different functions multiplied by each other, so it might be x cubed sine x or something, and then you differentiate both of those separate functions and multiply each of them by like that. Now that links through to the quotient rule. Now this is in the formula book, and you may be able to distinguish the similarity between what's written up here and what's down there. Apart from the fact that that's this one taken from that one instead of added, it's exactly the same thing in effect. So hopefully by considering that, you can have that to help you in the exam room when you need to go for a product rule. All right, now what we're going to look at today is this little fact here. If you've got a function in the form x equals a function of y, so you're told something about you're told about how to get x if you know y instead of the other way around, if you see what I mean. You can use the fact that when you divide 1 by something, you get the reciprocal to find dy dx. So you can do 1 divided by dx dy, which will be a relatively simple thing to work out, and then that gets us to dy dx. So we're going to do one example of that now. So here we have, pause the video, write it down, have a little think about how you might do it before watching me take it through. And we've got, you don't need to worry too much about this. Is setting the domain that's going to work, and we're trying to get to here. So first of all, we're going to be using this idea, so we're going to do dx by dy, and that's simple enough. Our circle of truth goes from sine y to cos y, doesn't it? So we can say that that will be cos y, and then we can say that dy by dx is going to be 1 divided by dx by dy, so that is going to be 1 divided by cos y. Now, how do we get from 1 over cos y to this? The clue is in this is being squared here, and we've got x in terms of sine, So we're going to use the I can't remember if we called it the mother or the daddy. I think it was the daddy of all identities, that sine squared y plus cos squared y is going to be identical to 1. And then I'm going to replace that into here. So I can say that, well, I'll do a little bit of work with it first. We know that cos squared y is going to be 1 take sine squared y, and then we could say that cos y is going to be the square root of 1 take sine squared y. X equals sine y, therefore x squared equals sine squared y, and at this point we can pop that back in over here and say that instead of cos y we've got the root of 1 minus x squared, and we have shown it. So we just need to, as required, that. And that's all I'm going to show you for today. I'd like you to spend a fair bit of time though working through the questions that, first of all, if you didn't have a chance to do all of questions 1 and 2, I think that would be worthwhile. So this is on page 249, exercise 9F. Questions 1 and 2 really cover what we were doing yesterday, and then the last example covers a fair bit of 5, 6 and 7 to be honest as well, but you also look out for when you'll need to use this, and question 12 as well at the very end. And then I look forward to seeing how you've got on with that. So I'm looking for you to be uploading stuff from the first lesson, the statistics lesson, but also from here. Now I don't mind if you do it just one upload after today's lesson for both the last 2 lessons we've had, that'd be fine. Alright folks, see you tomorrow.